Hi and welcome to Geeks for Geeks. Today we will be discussing the problem Padovan sequence. So let us first see what do you mean by Padovan sequence. So before I exaggerate this Padovan sequence and tell you what is the meaning, and like you should have a mindset that basically this is a variation of Fibonacci series. Okay, so why I tell this? Because Fibonacci series is the most frequently used series in DSA. And the very next thing is in Fibonacci series, we use the result of the previous two computed result to compute the current result. Like, what do you mean by Fibonacci series? We define Fibonacci series as fib of n is equals to fib of n minus 1 plus fib of n minus 2, and fib of 0 and fib of 1 is already defined, the value is given. But that is why if you don't know Fibonacci series at this point, consider learning this and then coming to this, because Fibonacci series would serve as a better base for you for discussion. Okay, because the probability of getting Padovan sequence is comparatively way less than Fibonacci series. So consider learning Fibonacci series first, then use it as a base to learn Padovan sequence and then solve the question. Okay, so now as I told you, this is a sibling. Padovan sequence is a sibling of Fibonacci series. So here also we are defined the first two terms, and the very first two terms instead of first two times, here we are given first three terms, and all are same. That is p of 0 is equals to p of 1 is equals to p of 2. All three results to 1, and then we have p of n is equals to p of n minus 2 added to p of n minus 3. This is what is asked. So now, so as in the Fibonacci series, as in this question also, you are given a value of n and you need to return the answer. You need to return the answer. Now it is also told that the value can be very large. So you need to do modulo 10 to the power 9 plus 7. So let's first take down this problem, and then we would at the end, towards the end, we would talk about this modulo thing. Okay. So now what we can do is, see, we can use this recurrence solution. See, we can use this recurrent solution and produce the result. How? That we can say that for 0, for let's find the value till 7 or 8. So let's say that we have 0 and then we have 1, 2, 3, 4, 5, 6, 7 and 8. Okay. And then for the 0th value, for 0, 1 and 2, we have the value as 1. And for the value 3, so 3 minus 2 is equals to 1. That value would be 1 plus n minus 3. That is 3 minus 3 is equals to 0. And that value would also become 1. This value would become 2. Now, very next one is for the value 4. For the value 4, 4 minus 2 is equals to 2. The value is 1, and 4 minus 3 is equals to 1. The value is also 1. The value would be 2 again. Then we come across 5. 5 minus 2 is equals to 3, that is 2. Let us go to 5 minus 2 is equals to 3, that is 2. And 5 minus 3, that is 2, is equals to 2 plus 1 is equals to 3. Then for the value 6. So for the value 6, 6 minus 2 is equals to 4 and 3. So the value would be 2 plus 2, that is 4. So this value would be equal to the value 4. And then for again the value for the value 7. 7 minus 2 is equals to 5. The value of 2 plus 3 is equals to 5 here. Then again for the value 8. 8 minus 2 is equals to 6. And then 6 and 5, that is 7. So this value would be 7. Okay. So we found out the value. This is how we can start filling up the stacks, and we can just simply use an array, define the first three values, and then by using those values we can calculate this progressively, we can calculate this progressively, we can calculate this, and we can move forward. Okay, so if you solve up the problem like this, the time complexity would be big O of n, because at each point we are just finding out the index and doing addition. So finding out the index is constant operation in an array, and doing addition is also arithmetic operation is also constant. So at each point we are doing only constant operation. So for calculating one value we are doing constant operation. So for calculating n values we would be doing big O of n operation. So the time complexity is turning out to be like this. And if you are calculating till 8, a size of 8 plus 1 would be required. So n plus 1 would be big O of n only. Why? Because constants are ignored. So that is why the space complexity would also be big O of. Now we found out that this would be the space and the time complexity. But let's optimize it more. Okay. So if you observe, like math, you don't need to come to this and then observe if you are if you're not a beginner. So point of concern is, like, let's just see, for calculating the value of p of 7 we need the access of who all. For calculating the value of p of 7 we need the access of n minus 2, that is this value, and n minus 3, that is this value. So even if I don't had these all previous values, it shouldn't affect me. Let us confirm this more. Let's say that we want to find out the value for 8. So 8 minus 2 would be 6 and 8 minus 3 would be equal to 5. So we just need the access of these two. So what we can do is, we can simply keep the last three values only, because we know that the last three values are the ones that are making up the results. Okay. The concept is comparatively similar. Let's understand with a simple analogy of this. Let's say I just say you that each day the amount of happiness the amount of happiness would be the of sum of the happiness of the previous 2 days. Let's say this is me, and for each day my happiness would be the sum of previous 2 days. So this is my previous day, this is my previous day. So to know the happiness of my current day, I only need the access of my previous 2 days only. There is no need of me to store the happiness from my birth till before this, that is previous. So to find out the happiness of any 2 days, we need the access of only previous 2 days only. Same analogy goes with this also, that to calculate the value of any particular point, we need the access of just previous 3 only, and that would be sufficient enough. Okay. Now the very next thing that it is told. So we are now know that we don't really need an array, we just need 3 variables, and variables contribute constant amount of space to the array. So that is why we would be taking down the space complexity from big of n to big of. Okay. Now the very next thing apart from this is what was the very next thing I told was this thing, that as the answer can be very large, compute it modulo 10 to the power 9 plus 7. Now what the heck is this? Let's see what the heck is this. See, let's say we are given that the answer should not exceed 5, and we are doing the multiplication of what? 3 and let's say 7. Okay, a is 3 and b is 7, and I want to find out what? I want to find out a plus b modulo m, because I don't want them to overflow m, and this value of m is equals to 5. I don't want a plus addition of a plus b to overflow with 5. So the formula is a modulo m plus b modulo m and then whole modulo m. Okay. So we would do the same thing. 3 modulo 5 plus 7 modulo 5 plus whole modulo 5. The answer would be 3 plus 2 and then modulo 5 the answer would be 0. Okay, this is what is known as modulo arithmetic, and this is the formula of modular addition, so that the value does not flow. So at each point of addition, we would directly use up this formula, and that would be sufficient enough because we are just adding the things. Fair enough? Now let's move forward and solve this problem. So int m is equals to 1e9 plus 7. Okay, and then we would be first storing the p1. Okay, that is the previous, the very first. So we need a trailing value of a, b, c. So sorry, we need a trailing value of a, b, c, and this would be current. Okay, this would be the flow. So the very first thing we have is the value of a, which is equal to 1, and the value of b, which is equal to 1, and the value of c, which is equals to 1 again. And then we would start. And let's take current also. Current is also equals to 1. Now let's start with the progress. For int I is equals to 3, I is less than equal to n, and I plus plus, and then when we go at this, then we would say current is equals to current minus 2. So current minus 2 would point to B, and current minus 3 would point to A, is equal to B plus A. We are having this. So now we have calculated the value of current. Now in the next iteration, current would go to C would go to B, and B would go to A. Okay, so we would make A is equals to B, and then B is equals to C, and then C is equals to current. Okay, at the end we would return what? We would return the value of current. Now let us see if this is working fine or not. Okay, now this is working fine because 9 test cases were passed. Now let us do what? At this point of addition, let us just implement the modulo thing. So modulo m, and then a modulo m, and then whole modulo m. Now let us see if this is going correct or not. Seems like correct. And yes, we were able to solve up this problem. That's it for today. Thank you and have a nice day.